Last one in your study guide is a min-max problem. I kind of summarized what they're asking for. They're asking for relative extrema. And then it wants intervals where f is increasing or decreasing. So the first thing I need to do is find f's derivative. Maybe I'll go to blue. F prime of x is equal to, well, it's the derivative of the first times the second. So we'll go first and second. Whoops, undo. So derivative of the red one, x, is just 1. So the derivative of the first times the second there is just e to the 2x. Come on. And then the derivative of e to the 2x is 2e to the 2x. So what I get is plus derivative of the second times the first. So I get x times 2e to the 2x. I just rewrote that there. Now what I'm going to do is, notice both of the, I need to set it equal to 0, and I look at it right here, I'm like, I don't know, I can't see it when it's 0 in this case, right? So what I do is I look at it and I say, oh, look at those two things that are underlined in red. They're both part of each of those terms. So what I can do is rewrite this as e to the 2x times something. Now, I just need to fill in what that something is. Well, the first little red line, e to the 2x, is the only thing there. So what I need to do is have a 1 there, so that when I multiply my e to the 2x back in, I get this thing. And then I get the other part is plus 2x. Done a lot of that. That should be pretty good. You should be pretty good with that. Now what I need to do is figure out what will make this derivative equal to 0. This term right here, no matter what I plug in for x, that thing's never going to be 0. I could plug in 5, 20, a million. I'm going to get a positive number that's really big. If I plug in a negative number, I just get like 1 over e to the something, which is just really small, but not negative yet. You should know that the graph of e to the x looks like this, right? I'm not worried about any units or anything like that, but it does. What it does is it goes and it's got an asymptote here, so it's never going to hit that axis, so it's never going to be 0. So anyway, that leaves me with this right here. For this part right here, I just need to set that equal to 0. Since the first part's always positive, then the whole derivative is going to follow whatever sign this underlined red thing is. So I just set that equal to 0, and I get x equal minus 1/2. That becomes my critical value. So I'm going to make a little chart for myself. In my chart, I'm going to go from negative infinity all the way up to negative 1/2. And then I'm going to start at negative 1/2, and I'm going to go up to positive infinity. I should label on my chart that this is x, and I should give myself a little bit of, and that this is f prime. So I know that it's 0, that the derivative is 0 at x equal to 1/2. Now I got to look at what it's like before and after that negative 1/2. So what I'm going to do is plug in some easy numbers. For example, I could plug in negative 1. When I plug in negative 1, I get whatever this is. I don't really care. And then this inner piece right here comes out to be 1 minus 2, which is minus 1. So what I have is a positive times a negative, which is a negative. Do the same thing for, say, 0. I could plug in 0, and I get e to the 0, which is 1. I can actually figure that out over here. Plus, this comes out to be a positive number, so it's a positive times a positive, which gives me a positive. So from here, I'm going to give myself some space. So from here, I know that, and I always like to be like, all right, it's negative, so it's going down, or its derivative is negative, so the function is going down. Here the derivative is positive, so f is going up, right? When I do that, I can see that I've got a low point, so I've got a min. I wrote what f of x was up there, so I can say, all right, this thing is decreasing on this interval, so negative infinity comma negative 1/2, and it's increasing on negative 1/2 all the way up to infinity. That's pretty clear. Notice the wording is find the relative extrema. It doesn't say find the x value, so I really need to find f of that critical value. So that's why I wrote this up here, so that I can find f of negative 1/2. That is negative 1/2 times e to the 2 times negative 1/2, which comes out to be negative 1/2 times e to the negative 1. I know that e to the negative 1, and if this was an FRQ, you could totally answer it and leave it like this and not do anything else. So you could even leave it in the previous form. But I want to recognize that I got e to the negative 1, because it could be a multiple choice type question. So it is negative 1 over 2 times e, because that e to the negative 1 moves to the bottom. It's a single power, so it just stays as e. So this thing is decreasing. All right, f, so I'm really clear. Decreasing on that interval, increasing on this interval. So there we go. Its minimum value at x equal to negative 1/2 of negative 1 over 2e. And that's my answer. Now, if they ask me to justify, then I have to go a little bit further, talk about derivatives from positive and negative. But anyway, this is good for this particular problem. You should be getting really good at these types of problems.